Go ahead and record this. All right, I want to welcome everybody to the PADS Professional webinar. We're going to also be talking about flex circuits that's been added to the tool. Before I get started, I want everybody to kind of understand that PADS Professional is based on Expedition technology. So we're really basically looking here at Expedition Lite. A lot of features have been added to this tool in the PADS Professional suite. So let's take a look at everything. So one of the first things is I work for EDA Direct. We are the distributor for the Mentor products, as well as a bunch of other products that we sell. A lot of them are the Mentor products, PADS and Expedition and Valor and so forth. So should you guys need any help with purchasing those tools or any support, you can give us a call here at EDA Direct. Today I'm going to talk about PADS Professional. It's an integrated system. It's not run by a net list. So everything is self-contained, meaning that the schematic and the layout are all integrated. It is a scalable suite that you can add options to. Very powerful, very complete system. What we're going to look at today is schematic capture tools that come with it. You've got 2D and 3D PCB layout. There's archive management tools, signal integrity and analysis tools that come with it. There's a collaboration that allows you to talk to your mechanical tools as well. And then you've also got manufacturing preparation and revision collaboration that all comes built with the suite. One of the first things that's always asked is about libraries. So Mentor is giving you guys a library that's going to come with the tool. There is the way to build your libraries as well. You'll have library entry management tools as far as symbol editors and pad stack editors, cell, part, layout templates. You have all the capability to build your own components should you want to. You've also got the ability to download over 10,000 parts that are available to you on the pads.com website. So there is a full starter library. It's designed by a company called Optimum Designs. They're a service bureau in the Bay Area. They also manage people's libraries for those that don't want to manage their own. So to get up and running really quickly, they've got IPC compliant parts that are available for you guys. Go to thepads.com and you can download that right away. We're also tied in with PartQuest, which is tied into the DigiKey catalog that Mentor has full access to. You guys can join this. It doesn't cost you anything. There's probably over 1 million parts now that are available to you. The nice thing about this is when you're searching for parts in the DigiKey catalog and you're part of the PartQuest team, which ties into the Mentor products, when you start to see like these little symbols here, there's little schematic symbols, lead-free and RoHS compliant symbols. That's going to let you know that they built the schematic cell symbol and they built the footprint for the PCB layout tools. So you can come in here and you can download those and bring those right into your library. They will be fully loaded with the properties that come with it. Let's go back here. So you will have the ability to add your own properties as well as them filling in the necessary properties that DigiKey has allowed, anywhere from manufacturing part numbers to the description of the parts, to operating temperature, and then should you require any other properties, you can add those as you bring them into your library. We also have a schematic capture tool. There's actually PADS is driven by DX Designer. So it's an easy schematic table-driven tools. You've got ease of use for reuse in there. You've got variant management tools. For those of you that are designing one circuit board and you populate it different ways, we can manage all that in the schematic tools so that you have multiple BOMs and multiple schematics without having to manually take care of those things. You're also going to have a constraint management tools that come with it. This is a little bit different than the PADS tool. It's all done through a single integrated environment in a nice little spreadsheet. This is linked into the schematic tool as well as the layout tool. So you guys can, whether the engineer wants to be able to put in his different classes, for example, or create his differential pairs, or whatever constraints that the engineer wants to put in, he can do that in the schematic, and then he can push that into the layout tools, and vice versa. The layout designer can also go ahead and put the constraints in and back annotate those back to the schematic. So you've got full constraints, being able to just build your boards correct by construction, for placement and routing, and it's going to maintain all those constraints, whether you're, like I said, in the schematic or in the layout tool. You will have full layout abilities with the PADS professional tools. You'll have sketch router, which is really powerful. Hierarchical planning and placements to help you with your placements of your designs. Dynamic planes that you can route through, kind of a WYSIWYG. And everything is constraint driven when you're doing your routing. So you've got that full constraints that you've got on there that you can turn on. You've also got some advanced technologies, HDI and flex circuits, and we'll get into that a little bit here at the end of the webinar. But you've got also 3D layout that you can do part placement with as well. You've got nice environment tools that are going to be there to help you. What I like most about this is what we've done with the GUI is you can place your cursor on one of these GUIs. If it's going to pop up and have a video that's going to show you how to use that functionality of the tool, which is really nice because some of you engineers aren't on the tool all the time. You forget how to use something, so this is going to be able to help you quickly and easily figure out how to use your commands on the toolbars. Okay. Also have key in command. So those are going to be available to you. Modeless commands like we have in the PADS tools. You can just type in if you want to change, like for example, the width of a component. We can just say change width and give it the actual width of that component. So you will have full capacity to be able to create your own environment with your key in commands. Yeah, if you prefer that rather than using your mouse. We also can auto-hide our tabbings to give a much clearer and bigger picture on your screen when you're designing. We can actually hide different menus like our component explorers, our net explorers, our display controls, our editor controls. So we can place those on the side or on the bottom of our menus, giving you a much bigger window to do your designing in. The display controls is going to be a pretty powerful tool. They've redesigned it to take advantage of all the new user configurables that are available. You're going to have a favorites tab. We've improved the layer controls. There's a global selection as well. So you're going to spend some time with this. There's a lot of capabilities and a lot of power in the display control that they've fixed up. And then there's an environmental select mode, which is nice. Back probably years ago, we used to have to select the mode that you wanted to be in. So you would have to select like the placement mode, and then you could go ahead and start placing components, and the GUI would be available to you. There's a lot of capabilities now, being able to select anything that you want. It's going to recognize what you've selected and automatically put you into that mode, whether you're doing placement, whether you're doing routing, whether you're doing just drawing. So just by selecting any of the entities in the board will automatically push you into that mode. There's also in that select mode that you can do a right mouse button. So once you've selected something, since it's going to push you right into that, whether it's placement mode or route mode or drawing mode, by pushing the right mouse button, you're going to be able to activate the commands that you can use with that tool. So very easy to do. Select something, right mouse button, push into whatever you're going to be doing, whether you're routing, you're adding components, moving reference designators. So very nice, easy environment in the select mode. Also in the select mode, you can pull down a selection list in the filter, and you can also, rather than digitizing onto the board, for example, we have a select menu that you can actually select what you want from that. This is separate from the explorers that are available, whether you're in the route or the Net Explorer. This will just allow you to be able to pick up traces, for example, if you want to, and give you a full description of what's going on with that entity. So a lot of power in the environment select modes, making it a lot faster for you able to get to what you want to do. Now, in the placement mode, we have a component explorer tool that we pull down. And what's nice with this component explorer tool is we can set this up with our schematic by, for example, selecting a bunch of components on our schematic, adding a tool or a property in there called cluster, and then give that a name to the group of components. Once we've done that, when we are in our component explorer in the layout tool, what's nice is we can select those cluster placements that we've created, and what's nice is we can drag and drop those right onto the board. So for example, here we have an analog area. We can actually grab the analog area. A circle will appear on the design. All the components from that sheet in the schematic will be inside of that circle, and then you can pull those outside to start doing your placement. So it gives a nice little way to be able to place your components. You can also display what you're looking for, whether you're cells or mounting holes or part numbers and all that. That can be set up easily with a display column. It's going to look more like this. When you start to do your placements, you're going to be, everything is set up in your clusters. I can now start bringing in those sheets of the schematic, and I can kind of get an idea on where I want to place those on the board. And then when I'm ready, I can actually start pulling those parts right outside from the inside of the circle. So you can see how easy it is to do a reuse, for example. And it also works in 3D. So you've got 3D capability if you want to be able to place all of your components, in the 3D world. So this is really nice in helping you with your hierarchical group placement. So you're going to find that you're going to use that tool quite a bit when you're doing part placements. What's also nice is we can also select inside of our component explorer, not only just the reference designators when we want to pull a part in here, but we can actually pull by part type names, for example. We'll also have access to spares or mechanical parts or drawings. So you've got a full array in your component explorer to add your pad stacks, your fab notes, your title blocks. All that's built into the component explorer. All right. Another nice feature of this that I really like is the netline visibility. So there's lots of ways that you can deal with this in the display control. Most of us are used to being these nets being rat's nested all over the place. It's very difficult to be able to see what you're looking at. But with the display controls in the netlines section, you can actually turn on mark nets and just see the nets that you want to use. So you can mark those nets. They'll display for you. You also have the ability to just zoom in on a certain area. If the rat's nest is within that area, it will stay. If it steps outside, then that will disappear. So this is a good way to be able to minimize your rat's nesting so that you're only working on those nets that you need to be able to visually see. We definitely have a lot of good quality routing with the PADS Professional tool. It's like manual routing, but we were able to use the sketch router, which is very powerful. You're going to have a lot of nice lines that come out of your differential pairs. It'll have the nice proper pad entry. It will control your widths and your spacing controls are all done with your routing. So very, very powerful routing tools. There's also an active clearance tool that comes with it that lets you kind of know what the clearances are of the components or the vias that you're routing around. So you can see here, it gives you like a little window here to let you know where the solder mask is, so that when you're routing your lines, you can actually see where that line can actually go, and without having to do any kind of DRC, you can actually get an idea of where the clearance is going to be. You'll also have delayed push and shove capabilities. So you've got dynamic push and shove, whether you want to do it online or real time, or do you want it to be a delayed? So here we can see we're pushing a line in here. We're looking for a delayed, and then see if we can get it in. It'll automatically push out, or we can switch that to where we're just routing and it'll automatically push and shove. So you've got a lot of high quality push and shove lines. Makes life a lot easier when you're doing multi-layer designs with lots of traces on there. So it's going to reduce your mouse clicks, having to just delete lines and put them back in. So I think those of you that haven't used the interactive router in pads, you're really going to like this one that is using the pads professional tool. You've also got the capability to be able to place lines in with the DRC turned on, but sometimes, you know, you're routing the line and you know that it's going to fit in there, but you've got like locked traces, for example, and you don't want to unlock that yet. You just want to make sure you kind of get a section in there and you'll come back to it later. So what's nice with the pads professional tool, we can actually lay those traces in there. We can unlock the ones that we want, and then we can come back in and we can go ahead and repair those traces that had DRC errors. And it'll look through the whole design and just clean those up for you. So you can see here, you know, we're trying to figure out how to get this trace around this pad. We know that there's enough space in there eventually. We've got a locked trace down here. So they're going to go ahead and unlock that trace. And then once that's unlocked, we can go ahead and select the repair button, and it'll automatically go ahead and repair those by pushing and shoving, maintaining the distance that you've got in your constraints. Very powerful. You've also got the ability to do hug routing. This is something we didn't have in pads, and I find it to be very powerful. So you've routed a trace, and then you want to be able to hug those traces with different routes. So you've got a lot of power in this. You're free to use this on any kind of routing layers and with vias as well. So basically, you're going to select the net that you want to route, and then select the net that you want it to hug to, and it'll automatically hug those traces for you. So I think those you'll find very powerful when you're using the flex circuits designs as well. We've also got the ability to do area rules. So unlike the pads tool where you have component rules, here now we can set up area rules. So we can set up an area where we want traces, for example, to be a certain width, and then maybe we want those traces to drop down to a certain width when we get into the BGA area. So just by putting area rules, we can set those up in the constraint editor, specify a rectangle or a square of what areas you want those traces to appear in and that are smaller. Very easy to set up, very easy, and it'll maintain those when you're routing them. So you'll find that to be a very powerful part of the tool. Area rules, only in the pads professional tool. You will not see that in the pads plus or pad standards tools. And then there's sketch routing, which is really powerful within this tool. I really like the way that it unravels everything. The escapes of BGAs is phenomenal. You can control the route via patterns on it. Let's take a look at some of this. On the BGA escaped optimization, you can see that we have a lot of tangled lines. You know, once you've got this into the algorithm with the sketch routers using, it's very easy to be able to untangle those lines using the algorithm. I can route those very quickly in and out of the BGAs just by selecting those nets, telling them how I want them to be routed, and then it'll route those automatically for me. Very easy to use just by selecting the nets. You can see here I'm telling it exactly where I want it to route. And you can set up, the layer restrictions and your netline organization and your differential pairs and your vias. So it's a very easy tool to be able just to grab those nets and then push it into the sketch router. Now there's two kinds of levels of sketch routing. We've got packed and we've got unpacked. Packed works really nicely when you want to pull all those lines together, as you can see here on the left-hand side. Very nice, tightly integrated. But if you're doing some match length lines, for example, or you've got some differential pair lines that are mixed in with your sketch routing, you might want to have those route unpacked, because you're going to come back in and you're going to optimize those or tune them so that they can start adding accordions or trombones to them to give them that line length. So by routing them in unpacked mode, it's going to give us a little more freedom by spreading those lines out to allow us to optimize those traces. So you've got two ways of routing, like I said, packed and unpacked. Then you've got the via pattern, and this is pretty powerful. You've got 34 possible combinations of vias. It's very easy to use if you're going to be routing from one layer to the other. So you select the via that you want to use. For example, this one was, single row and 45-degree angle. If we're not happy with that, we can undo it. Go ahead and just switch the via out. We got a dual row, 45 degrees. Maybe we find that that's taking up too many channels. Maybe we don't like the angle of that. Maybe we want to switch it. Here you've got a dual row of 45 at a different angle. So you've got 34 different possible combinations to allow you guys to be able to create the spacing that you need when you're routing. So this will take up some of the routing area, but by controlling those vias, makes a big game changer. Sawtoothing. We do have the ability to do sawtoothing for differential pairs or match length lines, automatic phase matching. You can control the accordions or the tromboning that you want to do, as well as the sawtoothing. So you've got all the capabilities to be able to control how you want the minimum spacing and the maximum height on those, as well as what has been added now is the sawtoothing. So becoming quite powerful when you want your differential pairs to match, and yet one of the differential pairs doesn't have any accordions, and you want to make sure that you're matching that same line. So you've got a lot of capability in the tuning patterns menus. Easy to add tuning as well. It's all you have to do is select a net, see if it's match length requirements on there. You can go ahead and add accordions very quickly, easily. It will match in with what's in your constraint files. Right now we're adding like some tromboning, for example. Maybe we can't get some accordion in there, we can do some tromboning. So there's a lot of capabilities being able to use that, as well as being able to adjust the size. You'll have a spreadsheet that's going to target your lengths so that you can actually easily see what your lengths are, the requirements on those lengths, and if you've met those. So by using the tuning meter and the tuning patterns, I can come in and easily tune my board to be the traces to be the right length. Very powerful tool that we see in the PADS Professional tool versus just in the PADS tool. And then sketch routing. Here's a DDR section that you can see how quickly it is to route those. All we do is we select those traces that we want to route, specify the layer that we want them to go on, and you can see how quickly and easily that is to route that section of the DDR. I really like the capability of this, the ease of use of it, and you'll find that your routing is going to be very high quality routing. You're going to be very happy with the routes that come out of there. And one of the other nice features that comes with this that you don't see in the PADS tools are the advanced topology support. So we can set up our vias to be chain link. We can set them up any pattern that we want to set up for our advanced routing, to how we want the routes to go, whether it's daisy chaining, using a tree format. So a lot of capability in that function. You also are going to have HDI vias. So if you're doing blind and buried vias, you're going to be able to add these very quickly, move from one layer to the next. The system will automatically know what kind of via you're using, what layer you're on, and then be able to add those vias in here. Should we look at these maybe in 3D, you can see how quickly it is that we can add these vias in and see exactly how they're going to be routing. So you've got a lot of capabilities with the advanced HDI routing tool. And then some of the other nice features that come with the tool is going to be some of the hyperlinks tools that are going to be available to you. So you're definitely going to have signal integrity, thermal analysis, analog simulation, design rule check. These will all come with the PADS Professional suite. So did you need to do any kind of pre-layout analysis, in the schematic? You've got full capability to do look for terminations problems or ringing or overshoot problems. You have an oscilloscope that you'll be able to use. There'll be a layer stack up that you can look at to find out how your layers are used, what metals you're using, impedance controlled information. So for those of you that want to do this before you start laying the design out, checking out your schematics, you've got full SI analysis. You also have post layout simulation and analysis. So for those of you that maybe send a design out and you want to check maybe a clock line or something that's sensitive to you in your designs, you have a full capability to do that in the post layout. You will also have thermal analysis capabilities. So you will be able to check out where you're having some temperature problems, should you need to add heat sinks or mounting holes. So full thermal analysis tool there that you can use. You will also be given new MCAD hyperlink DRC. So this is more of an electrical check. This used to be an option. They've now thrown it into the tool. This will allow you to do EMI or signal integrity or SI or PI. Full range of design rule checks that you can check out. Maybe you want to check out, do I have impedance problems with differential pairs? Do I have traces that go over multiple power planes that I need to check? Do I have long stubs? Do I have traces with too many vias? Do I have metal areas that are floating around? So you've got a whole bunch of EMI, PI, and SI checks that you can run separate from your DRC that you would run for spacing and connection violations. You'll also get a PADS analog simulator, very much like PSpice, but more up to date. The thing that I like about this analog simulator is when you build a model in this simulator, you don't have to rebuild it in the schematic. You can actually pull from this analog simulation tool and bring those what you've simulated right into your schematic. So very powerful tool. I highly recommend those that need analog simulation that they do an eval guide with this. I think you'll find that you really like playing with this tool. And then you're going to have manufacturing preparation tool that comes with this. So you'll be getting the drawing editor and you'll be getting FabLink, which is going to allow you to do panelization. So you'll be able to use the FabLink tool in XE. For those of you that want to panelize your own boards, rather than having your contract manufacturers do it, very easy to set up your designs. It's going to ask you how many rows, how many columns you want. You specify that, it'll automatically look at your design, bring that into the panel, easy to set up, and then you can just push that into, create all your ODB++ Gerber data. You'll also have the ability to the drawing editor that comes with the tool. So these are all expedition tools that are going to be thrown in here. So if you need to create your drawings, your assembly drawings, and your drill drawings, you'll have all the capability to add your drill charts, your fab notes, your testing, everything like that using the drawing editor. Very powerful tool. You can also build a lot of templates, so it's very easy to grab those templates and then add them onto the board. Okay. And then there's 3D capabilities that come with it. Really like that 3D has been added to the PCB world. You've got access to over 4 million step models that are available to you in the ECAD world. We support DFR analysis as well. When you're in your design, what's going to happen is your screen, when you move it into the 3D world, your screen's going to split into two. You're going to have two views on one screen. You'll have your 2D view on your left. You'll have your 3D view on your right. The 3D view comes with its own GUI, comes with its own display layers. So you'll be able to set up images there and be able to manipulate that data with its own GUI, which I like. And what's nice is you can place components both in 2D and in 3D format. You're in the 3D format and you're placing components, like you do in the 2D world, you can see exactly what's going on. As you move parts closer to each other, they kind of like go invisible or transparent until you actually make the clearances. You have kind of the same capabilities in the 3D world. Everything's kind of color coded though. Yellow indicates that we have the less optimal area that we'd like. Red indicating that it's less than the minimum. So we have some placement problems that we would have there. So it's going to give you the tools that you need to be able to handle 2D and 3D placement. And you're also going to be able to see everything that's on the design. So whether you're looking at solder mask or 3D components or land patterns that you want to see how they're going to fit onto the land patterns. You can see all the traces, whether they're internal or external. You're going to be able to see the plane layers that come with it that are designed. Silkscreen will be visible to you. You also see the solder mask, and then there's other things that you can add on to it. We can cut the design into different planes should we need to do that, and we also have a Z-axis scaling as well to make the board thicker, so we can actually dive inside and see how traces were routed. You've got all the different views, whether it's top, bottom, left, right, and I'll show you that when we get into some of the 3D stuff with the flex. You'll have a 3D design rule checking that's going to come with the tool. So this is actually very nice. Rather than bothering your mechanical group, ask the mechanical group to give you the enclosure that the board's going to fit in, and you can actually run DRC checks in here to find out, are you having component issues with maybe them being too close to the enclosure? Do you have enough spacing in between the components? Whether you're reflowing or soldering components on. So there's a full electrical, or not electrical, but a full DRC spacing check that you can run on the tools. You'll also be able to output and import and export the data. So we can import step models. Like I said, we can import the enclosures, components, heat sinks, brackets, things like that. And we can export out step models, 3D, PDF, JPEGs, BMP, TF, PNG files as well. And what's nice of being able to import some of these models, not only do we have the step models for the components, we can actually bring in the enclosures, like I said, so the top and the bottom enclosures. I can bring in mounting screws, mechanical screws, heat sinks I can bring in. I can actually also bring in, secondary PCBs to see how everything's going to fit into the enclosure on my design. There's a lot of capability that way. And then there's also the PDF file export. So we can output intelligent PDF files. Makes things nice when you're going to meetings or if you want to deal with customers. They'll have access to being able to look at the design. They can turn things on and off. Maybe they want to turn the brackets off. Maybe they want to turn the enclosures off. So you've got a lot of capability for them to be able to look at your design, check it out without actually having to be in the design itself. There's also a collaborator that comes with the tool. So for those of you that are using Pro E or SolidWorks or Solid Edge or NX, we have the capability to be able to talk directly back and forth between those tools. So what's nice is we can, with this tool, is we're going to be using an IDX file format. We can actually just pick a path or use email to talk between us and the mechanical group. And then we can pick and choose what we want to send over to the mechanical group. A lot of you are using IGES files or ASCII files and things like that. This is going to be a little bit better because we can pick and choose exactly what we want to give to the mechanical group. He doesn't want to see all the little 0402 resistors and capacitors and all the small components. So we can pick the big components that we want. We can pick the component layers that we want, the outside layers, so that he can see the traces as well. It's a pretty powerful tool. It's easily pushes into CircuitWorks, and then by pushing into CircuitWorks, we can push it into SolidWorks very easily. Same thing for Pro E, Solid Edge, and NX as well. And should the mechanical group decide to move some of these components because maybe they're interfering with something to do with the mechanical enclosure that they have, he can also move these components into his tools, SolidWorks, Pro E, whatever, and then we can back annotate that into the design, and it will let us know exactly where those components moved, and we can agree with them or disagree. And so it's a nice way to be able to talk back and forth with your mechanical group. one more thing before I go too far, the next thing. You can also output step models. So if you don't want to just send all the different parts and all that available, you can actually output the whole thing as a step model and then export that and give that to the mechanical group. Okay. Another nice tool is the PADS Professional is giving is this archiving tool. So we can archive to a vault, for example, and we can also restore those archives very quickly and easily. And one of the nice things about the archive tool is engineers can go into this tool, they can look at their schematic, they can look at the board that was laid out with actually having to be into the schematic and PCB tools. This will allow them to do a bunch of comparisons. Maybe you want to know what the differences were between Rev A and Rev B. I can run a graphical compare and it's going to show me and highlight what the changes were. I can do markup and red lines. Say I'm an engineer and I'm getting ready to do some spins. I can actually come in here and place some post-its to remind myself things that I want to do on the next spin. You've got full reporting on the design. So very powerful archiving tool that you should definitely use when you want to place these designs, or maybe even save a design to a certain level and maybe go off on a tangent and start doing some experimenting on a design, but you'll always have this as the main one that you can always copy from and start over again. Now there's a bunch of other add-on tools that we can add on to the tool, and I'm going to go through those. So you can see we've got a bunch of different either hyperlinks tools or some FPG optimization tools that are available. Flex circuits also an option. So chip on board, this was a nice tool back in the 80s. A lot of people were doing a lot of chip on board. I am starting to see this come back a bit with some components. So we do have the ability to do wire bonding or any kind of chip on board capabilities that you might need. Embedded circuits, so if you're doing embedded passes, the PADS Professional or Expedition tool handles this very well. So you'll have that capability. We've got a multi-trace router in there that allows you to select certain differential pair lines, for example, or match length lines. We can select that group of lines. We can automatically route them and tune them. This is powerful before you start routing anything else. So you do have the multi-trace high-speed router that's available. You also have the PADS Professional FPGA optimization tool. So this is going to work with your DX Designer schematic. You know, this is also, instead of you doing all that pin swapping when you get into these huge BGAs, we can actually go in, work with the FPGA engineer, move blocks of pins so that we can escape easily out of the BGA, making routing a lot more smooth, a lot more professional, makes a lot more sense rather than doing all that manual pin swapping just to get to your traces outside of these huge BGAs that are now being designed. Highly recommend that if you've got like 2,000 pin BGAs that you're using. You also have the ability to use the Hyperlink's DC drop capabilities. So for those of you that need to find out, do I have enough voltage that's going to run through my planes? Am I going to have some areas where the voltage might not be maintained? DC drop's going to give you a nice visual of that area, and then you can decide whether you need more metal or what you need to do to try to maintain that voltage throughout your planes. Very nice tool. Also have Hyperlink's DDR capability for DDR 1, 2, and 3. So this is going to help you with resolving typical SI problems. Maybe you have overshoot or undershoot, or maybe some ringing with your differential pair lines. So anything to do with DDR 1, 2, and 3, we have pulled that out of the hyperlinks and made that available for the PADS Professional tool. You'll also have RF capabilities. So there's the dynamic link to the Agilent ADS tool. You've got instant simulation from the schematic, which is really nice. You can lay out your RF circuit the way you want it to look like in your schematic. And then when you bring those parts in, it'll automatically put them in the right order when you've got it into your footprints. We can reuse RF circuits flooding vias around RF circuits or on planes is very simple and easy to use. And you can also, if you need to do simulation by sending it to the Agilent ADS, we've got a full link into that. So you've got a lot of RF capabilities available with you as an option as well. And then you have the Flex tool. So we've got, this is something that's been added here this last year, very powerful. I'm going to show you a little bit of a video on it before I get into the demonstration. You might hear the word expedition in the video, but pay no mind to that because PADS Professional is using expedition technology, so it'll give you an idea of what the Flex capabilities are. Let's listen to this little video here that I've got for you.
Flex PCBs are used everywhere in industry, from digital cameras, hearing aids, pacemakers, to health trackers, and much more. A rigid flex design typically consists of multiple inner layers of flexible circuits and rigid regions typical to everyday PCBs. These are often found in cell phones, LCD TVs, antennas, laptops, and many more applications. Expedition's Correct by Construction Flex Design technology simplifies the creation process, allowing you to focus on optimized form factor and quality. Expedition does not define flexible regions by zone, but by board outline. You can individually define each stack-up per board outline, simplifying the setup and minimizing the impact of changes later in the process. Flex designs are electromechanical projects that require deep collaboration between mechanical and electrical engineers. 3D technology is especially important for flex designs. You can quickly identify design issues, ensure bins are in the correct locations, and immediately validate your design, taking advantage of design real estate in all 3 dimensions. Mentor has partnered with all of the major MCAD vendors to provide true collaboration between ECAD and MCAD engineers. This bridges the gap between the 2 design domains and encourages collaboration throughout the entire design process to ensure that all design requirements are met. Not only can you validate the design in Expedition, you can collaborate and exchange data with the mechanical engineer using STEP or ProStep format. Collaborating on bend areas, multiple outlines, multiple stack-ups, bend properties, and more ensures that all requirements in the ECAD and MCAD domains are met. Flex designs have critical design requirements that must be met in order to ensure quality of the overall design. Before the data is sent off to be fabricated, Expedition provides robust, updated design rule checks to identify critical issues. The Hazard Explorer helps identify problems immediately, so issues can be corrected long before the design is sent out to be manufactured. Flex analysis is also fully supported within our integrated simulation toolset powered by hyperlinks. The bend area drives the 3D board mode, visualization, and DRC. Defining a bend area is absolutely critical in a Flex design. In Expedition, you can automatically detect if vias are placed in bend areas or if traces are not perpendicular to the bend area, which can cause reliability and other issues. Expedition provides dynamic plane class assignment to define the plane hatch. You will have the ability to easily define the plane class with a predefined hatch pattern or define a custom hatch angle needed for your flex region. It is absolutely essential that the correct design requirements are met and the exchange of data from the designer to manufacturer is seamless and requires as little documentation as possible. Improved ODB++ allows users to add the defined rigid flex regions and define the associated subset of the master stackup, thus allowing the manufacturer to fully understand the design intent. With Expedition's Flex Design technology, you'll have the competitive advantage you need to significantly reduce design time, increase overall quality, and reduce schedule risk.
Okay, so before I get into the resources here of this, let's take a look at PADS Professional Design here. So here's a design that we just saw. Very easy to create. These are basically blocks that we can draw in here using add a rectangle. And basically we draw in what we want to see, and then we can double click on those and we're giving them properties. So you've got, red is the board outline. We've got route borders here. We've got bend areas where we want the bend areas in here. So it's very quick and easy to be able to create those. Okay, and then you can also see what it looks like in the 3D world. Okay, so now probably the next step would be that we want to add components on here. So we've got our component explorer over here that we can drop in all of our components. Let's go ahead, and I've got those placed already. So here's all the placement parts on those. And we can see how those are going to be placed and all that. We can also go over to our 3D world here, and we can turn on our, let's see here, let's turn on our components. Pop it into the 3D world. I can see now where my components are going to be. I can look and just see how those are easily being placed and where I want the location of those. I can look at the different views that I want to very quickly and easily. You know, so if you get caught up using the rotation command and find yourself lost, it's very easy to come right back to those. Okay, so now we've got the parts that are placed and everything, and then now we're ready to go into routing. You can see how quickly, easy you can route this board. I did leave some areas in here to show you the hug trace capabilities. Let's go ahead and also look at this in the 3D world. Now that the traces are on there, the vias, let's look for holes on the board, component pads. So now I can see what my design is starting to look like with the traces on there and everything. And then let's go into this little area here with the hug trace area, so I can show you guys how powerful this is here. So let's zoom in here a little bit. What we want to do is be able to use the hug trace. We're going to do a multiple hug trace command. So we click on that. It's going to give you this. We want to graphically select all the different net names. So let's go ahead and use our control mouse button. We're going to select these nets here, for example. And then we're going to go ahead and make sure that they have a separation of 0.4. We're going to apply those. So now they all have a separation of 0.4 with a width of 0.1. And then we go ahead and select where we want these to route. So we picked our traces. We want it to start here, and we want it to end down here. And we want to push it into the middle of these traces. So it will quickly and easily, we can go ahead and route those with each other very quickly and easy. Let's close this out. And then we can zoom in here, and then when we want to just connect them together, it's easy by just grabbing them and dragging and dropping it, and we can make those connections. Okay, so it's very easy to do your hugging of traces very quickly and easily. We go into the 3D world, we can see that those have been put in there. So very easy to be able to route those, and then be able to look at your design while you're routing that in the 3D world. So now that we've got that, the board's all done, and we've got our bend areas in, and now let's go in and let's take a look at once we placed this whole board, and now we want to bend it in to the requirements that we've put in for the properties. So now I've got the tool there. Everything's bent the way it's properly done, and now I can take a look and see where I might have some problems with the design. So everything looks kind of nice and good, but why don't we bring in the enclosure that we want to see with the tool. So let's go ahead and go to the 3D world here, pull down menu. We're going to import an assembly file. Here's our assembly file. We're going to open that, and it's going to read that in for us. So now we've got this assembly that we've got with the board. We can see that it fits inside of there. We've got a little bit of a problem here. Looks like we've got maybe one of our bend areas is sitting outside of the enclosure. So let's do this. Let's go to our assemblies here, and let's add the top, the LCD, and the bottom to it. That's going to add those in there. We're going to turn off the LCD. We don't want to see that. We don't need the top enclosure either. So now let's zoom in here, and we can see, yes, we definitely have a problem with the bend area. So let's go to the two-layer area, the screen. Let's go in here and pull up our bend areas. We can see here where they are. Okay, I'm going to double click on that bend area. It's going to bring it up to me, let me know where it is. We want to move this over a little bit. So let's move this over maybe to here, and grab the other one and move it over into here. Okay, that should take care of it, I hope. Let's look at the 3D. Okay, yes, it does. It's definitely made the change for us. We can see now we've got a nice gap. We're not protruding outside of that layer. So that makes it really nice to be able to look at our flex and be able to move that, you know, in real time. You do have the capabilities, you know, using in the 3D world to be able to take things transparent. So like for the bottom here, I can use the transparency to make it solid, or I can come in and I can make it see-through, so I can kind of see what's going on inside there, with also being able to see the enclosure as well. And you can do that with everything, whether you're doing the visual of on the LCD. I can do that same thing with the LCD if I want to. Come in and make it transparent so I can actually see what's going on and see through that design. Okay, so you can see how easy it is to be able to deal with the flex circuits, you know, inside of the tool. Makes it very easy to be able to add those. One thing I didn't show you was you do have the capability to take a look at your stack up editor, you know, and you can see what's going on in here, how easy it is to set up your flex core, onto your signal layers, your cover layer. So all that capabilities here, you can, you know, pick and choose what you want to use, substrate that you want to use, whether it's adhesive or a stiffener, for example, you know. So that's all set up in your setup stack up editor. Okay. Alrighty, so before we do that, let's go into the rest of the PowerPoint that I have. Okay, let's talk about resources. So some of the resources that are going to be available to you guys, I highly recommend that you look for these. There's a lot of technical information that's available. Pads.com has a lot of online videos, seminars, technical papers. You can also go to our site at EDA Direct. We have a lot of videos that are available to you to be able to check out the different technologies and the different software packages that we use. So I recommend going there. Also, Mentor Graphics has a YouTube page. So if you're in Google or whatever you use for a search engine, type in Mentor Graphics YouTube. It will bring up all the different capabilities, whether you're in Expedition, Valor, Pads Professional. So you'll find a whole bunch of videos and a lot of information that's available there. You will also have the ability to, when you purchase the tool, for the first 30 days, you'll have free on-demand training. After that, there's a subscription fee that you can use for the year, and you'll have full on-demand training that's going to be available to you. I am starting to see more of on-demand trainings than people actually coming in and doing training at your facilities. So with the technology today, you know, videos and all that, I highly recommend that you purchase the on-demand training for those of you that aren't using the tool all the time and need to get refreshed on capabilities. And then for those of you that want to play with the tool, we have full eval guides, whether you're in Pad Standard, Standard Plus, or the Pads Professional. We also have one for Expedition as well. All you have to do is get in touch with us at EDA Direct. Get in touch with one of our salespeople. We'll be glad to set you guys up with a 14-day eval. These are very powerful. These are going to show you guys how the tool is used. Once everything is set up properly, how we can be pushed in and out of schematics into the design, constraints, 3D capabilities, signal integrity capabilities. So for those of you that kind of want to get your hands on it, highly recommend using the eval guide. And then should you have anything, any questions that you might have, you want to get your hands on the software, give us a call at EDA Direct. We'll be glad, ask for any of the salespeople, they'd be glad to help you. My name's Jeff Keister. I'm the FAE. Should you need any technical advice, you can always get hold of me there as well. And then I'm going to leave you guys with a video here before I sign off, one that I found online that they created. So I want to wish everybody a good rest of the week. And like I said, should you have any questions, give us a call here at EDA Direct.
The design process is different now.
All of your devices, including your watch, you know, the PCBs in there with very complex circuitry.
Unlike in the past, smaller startup companies are now developing more and more complex products, and with that they require powerful tools to simulate the potential issues that could happen.
If you take any of the consumer market, it's all about being first to market. If you're late, you've lost revenue.
PAS Professional gives you the tools as an engineer to crank out a PCB that just works the very first time.
The independent engineer who does everything can easily use this, from schematic to layout to simulation analysis.
It's a set of design tools that an individual engineer who needs to be able to control all aspects of the design flow can pick up and use.
This incredibly powerful simulation tool that has previously only been available to the large enterprise companies is now being made available to smaller startup companies, and that can be incredibly crucial for the successful launch of their product.
They want to know that they have a migration path as the company grows, as the technology needs grow.
Engineers in the industry today who are looking for an ECAD design tool, PAS Professional is the tool that you should go for.